Okay, we're at day 9. Oh, okay, there we go. We're at day 9. Not to be confused with streamer day 9. Let's see. I don't know. It's been easy so far. I hope it stays that way. And I'll be able to stream, I think, the next through day 11, but then the 12th day I'm traveling, so I can't stream that day. I'll try to take my laptop with me and solve it on my laptop, but probably won't be able to do it live, or probably won't be able to record it. Oh, is this not over? It's not quite over. Here. Uh, okay. There's the numbers. You slide down the fire pole. Movie theater has a big pile of floor. The anticipated also here redecorating the theater by switching out some of the square tiles. Some of the tiles are red. To find the large rectangle that uses red tiles for 2 of its opposite corners. These are where the red tiles are located. You can choose any 2 red tiles as opposite corners of the rectangle to find the large rectangle possible. Okay, so if we just do all pairs, so 2 and 9, that's 7. 7 and 2, it's 8 and 3. I see. Okay. There are 500, so we can just do all pairs. That's fine. Okay. Uh, let's see. Split it by the comma, and then they're both numbers, right? Okay, these are just points. Tuple. Close map. Close tuple. And then we just want all pairs. Or I point 1 enumerate points for J in range 5 plus 1 through n. Let's see. It's going to be or 0.2 equals J. So it's the absolute value of 1 plus 1. Let's see. What is the largest area of any rectangle you can make? Okay, part 1. 0. So part 1 equals max of part 1 and this number times this number, close max, and then print part 1, 9. That's right? Cool. The elves just remembered. What time is it? Okay, that was like 3 minutes. Great. They can only switch out tiles that are red or green. A red or green tile. Wait. Every red tile is connected to the red tile before and after by a straight line of green tiles. What? Tiles that are adjacent in your list will always be in the same row or column. Oh, look, they always share a number. In fact, it just zigzags. It just zigzags back and forth. Interesting. Okay. Can only include every red tile is connected. Tiles marked X would be green. These are the green tiles. Everything on the inside. Interesting. The large community can using only red and green tiles is area 24. Wait, why can't it go further? Oh, you still have to pick red tiles. The rectangle must still have red tiles in the opposite corners, but any other tiles inside must be red or green. I see. So, does it have to be adjacent only? Hmm. Need to draw some pictures. Because here you can take an interior point and an interior point, and that would work. So these are 10 to the fifth? But 10 to the fifth times 10 to the fifth. I don't think you actually want to fill out the grid. Need a fast way to tell whether a point is inside or outside. Because we don't want to be checking all the points. Does it always alternate? It looks like it does. Also, okay, is this clockwise or counterclockwise? Which direction are we going? Nine, five. Is the first one rows or columns? 7 column, 1 row? No, 2, 5? No, 2, 5, 2, 3, 2, 5. So it's column then row. So this is 7, 1, 11, 1. 11, 7. So this is going clockwise. This is 9, 5, column, row. So it went down. No. Column is the same. Yeah, so it went down. Row is the same. And then went right. So same thing. This is going clockwise. Okay, it's turning clockwise. Okay, so you can always do 2 adjacent points. But then if you pick 2 arbitrary points, how do you know whether you're clipping or not? This is some sort of segment tree? Ranges? Intervals? Or is this something with compression? Right? Because we can just do 1 step each. We can do length compression, right? When we compress the distance of the sides. Because you're always just stepping in a cardinal direction. So you could imagine it's just 1 step in each direction. Does that work? And then you do length compression. And then when you compare 2 points, you just do it in the compressed version. I guess we just see if we end up with any duplicates. If we collapse on ourselves. If we collapse on ourselves, then that's a problem. Oh, but we can actually just compute out all the rows and all the columns. And then do a mapping. Do a mapping between each one. Yes. I think. Right, because then it's just a mapping. And then the space is much smaller. And then we can actually just flat out do the points much simpler. Right? Okay, okay, okay. I think that works. Okay, we take all the x's. Or we take all the rows. Okay. Sorry, it's columns and rows. Oops. Yeah, and then we're gonna map them. Okay. So calls, rows, and calls is actually just the first number, or, and then this is And then we can sort these. And then the other thing we can do, we can make a reverse mapping. Yeah, I guess we make a reverse mapping for them. Uh, right. Um, there's probably a way to do this with comprehension. I don't know. It doesn't matter. Uh, wait, what was I thinking here? Um, for each, right, okay. For I see in rate calls, I got it. For a certain value, it maps to the index. So quiet tonight. Yeah, that's okay. Comma, and then we do the same thing for rows. Whoa, do that. Wow. Okay, so then we can do point to compress point, I guess. Uh, Compress point, I guess. Uh, Given a point, we will return a tuple with, I think it's columns first. Right? Okay. Because we don't even have that many unique. Oops. This is silly. This is a set. This is also a set. List sorted. Call. List sorted. Rows. There we go. That's better. Then we have columns and rows. We have this. I don't want to know how many rows and columns do we have. I don't even think that much. Compress point. Did I not save? I did not save. Yeah, this is tiny. So we can make the thing 250 by 250. And then we just X out the actual points. And then we can easily check. So we just want a 250 by 250 grid. Do I just want to be strings? No, because I want to be able to easily change them. And I think that works. Do I need to be able to go the other way? I should be able to go the other way, right? Oh, right. But that's what this lets me go the other way pretty easily. Excuse me. Okay. So now I'm just going to mark every point to point. Yeah. Okay. And then I want to pairwise, although I could, and I can re-add the final point. Do I need to do that? Probably. Uh, and then pairwise. What's pairwise in itertools? Yes. For point one, point two in okay, so we're gonna compress point, which gives us a column and a row. And then so in our grid, this down. Well, I guess we should just figure it out. If C1 equals C2 for R in range R1 to R2 plus 1. Is it always bigger? No, we don't know that. Whichever one's bigger. If R2 is greater than, no, is less than R1. I'll just use min-max. Min, R1, R2, max, R2 plus 1. Grid C1R equals blah. Else. Doesn't matter because the ranges are equal, right? And we just do this to all the points. Okay, and that's fine. Now we do all the pairwise points, and then we just check to see if everything inside is okay, right? We do the same as above, except we're doing it on the grid, and we're checking to make sure it's valid. Right? And enumerate points. Hi squeak. Or hi just. Hi squeak. This should work, right? Since we compress the points down, now we just need to pick the 2 points. We have the 2 points. Well, except we want the compressed version. So I guess we'll do it the same way. C1, C1, R1. C1, R1 equals compress point 1. And C2, R2 equals compress point. And the second point's J, which is our second point. And then now we need to just verify that it's a valid rectangle by making sure it's all hash marks. For R in, I guess, C in range min, C1, C2, whoops. I know how to type. +1, right? R1, R2 to the max. Streak. What am I writing? I'm doing advent of code. Doing this. Adventofcode.com. And then okay. Is okay. If grid CR, if it's not a hash, then is okay is false. How long time you write on Python? A long time. Decades. I'm an old man. 20, 25, 25-ish years, something like that. I've been writing Python for a long time. We can break, right? Because at this point we know that it's not possible. If not, is okay. Break. If okay, so if it is valid, we can. Where am I from? I'm in the States, United States. I'm in California. Let's see if it's okay. Then we need to calculate the area, and we calculate the area by uncompressing the points. Oh, we don't have to uncompress the points. We have the uncompressed points. It's here and here. Then the part 2 equals the max of part 2 and the area given, which is same that we did before. This. We should specify what point 2 is here. like we did here. So we may as well make this point too. I think that's correct. That's not right. All right, let's figure out what we did wrong. Let's do the sample. We only got 18. Cool. If is okay is not valid because I'm just trying to break early. I'm trying to make sure everything in this grid area is okay. Well, I got the wrong answer here. The answer is supposed to be 24. This is pretty small. Let me print this grid. So after doing this, well, these are all the points. This is like 4 by 4. Grid R, only like first 10 characters. That looks correct, right? No, that doesn't look right. Is it rotated? Did I rotate it by accident? I might have rotated it by accident. Oh, because this is columns, actually. Right, the first number is columns, which is super confusing. I think this is correct. It's just rotated. I mean, technically it doesn't matter, right? Did I relocate to the US? No, I was born in the US. What am I doing wrong here? The first one is columns, the second one is rows. Does that matter? It doesn't matter for any of this. Let's see. So the biggest rectangle is between 9, 5, and 2, 3. 9, 5. Oh, for some reason, it didn't like that. I didn't fill in the inside. I'm so stupid. Right, because I didn't fill in this square. How do I fill in the inside of the rectangle? I don't know. I don't know. How do I fill in the inside? I guess I do a flood fill, right? How do I do this? I go left to right, and I determine, and I just count, right? I'm inside. Oh, but that's not outside. Anyone can be stupid. That is an oddly racist thing to say. You're inside. How do you tell if you're inside or outside? Shoot. I don't know. How do I know if I'm inside the grid or not? Right. This is inside the grid. Well, I guess if you have, well, if on four sides you're touching, then yeah. But that's not the only case. There are many cases where you wouldn't necessarily. Uh, Let me see what the full grid looks like. Reset. Oh, it doesn't. Uh, this is what it looks like. This is what my shape looks like. Oh, that's hilarious. That's funny. Okay, so is it always the case if I run horizontally? I guess it depends. What goes on up here? Inside? Oh, here we're not inside. It's outside. How do I know if I'm inside or outside? What if I flood fill the outside? Yes. I can flood fill the outside the grid. Here it's flush, but here there's extra space. And there's extra space on the bottom, I assume. Oops. 250, right? Yeah. Yes, I flipped it on the outside as invalid. I can do that, right? Okay, okay, okay. Python is my main programming language. Sure. Python or JavaScript. Flood CR. Um, let's see. If C is less than 0, or R is less than 0, or C is greater than equal to 250, or R is greater than equal to 250, do nothing. If grid CR does not equal, what do I do, blank? Return. Otherwise equals I don't know, X. And then flood just the 4 cardinal directions. And then I just want to flood 0, 0, because I know that's not in it. And then we can print the grid. That's incursion depth. Then I guess we'll do a queue. Take the last item off, column and row. Continue. Continue. And then here we just add right? Yep. That should finish, right? Okay. Why didn't that work? Oh, it kind of did. Okay, so that worked. Oh, it didn't make it over here. Right. Okay. And we also need to add column 249, 0. Wait, let's try that. Hey, there we go. Okay. And then now we can go through and just equals X. then it's not okay. We don't need to output anything. Oh, what am I printing? What am I doing? Yay, that worked. Okay, point compression. Okay, that was a little slow, but we got there. Oh, looks like 5 other people got it. That shouldn't have been that hard. I made some careless mistakes. I came upon the algorithm pretty quick using point compression. Oh, am I dropping frames? I'm dropping frames again. I don't really understand why that happens. I think it has to. I think it's my ISP. I think my ISP is garbage. I'm sorry. I'm sorry. My ISP is garbage. I'm definitely dropping like half my frames. Sorry. Okay. So what do we do? Because we got what, fifth today? Yeah, fifth. We could have been faster. Day 9. Oh, wow. Was it really 45 minutes? Is it really that late? Oh my god. Oh my god. Part 1 we did so good. And then we spent 1,000,000 hours. Okay. Okay, we came upon point compression pretty quickly. Point compression is fast. Uh, it worked, no problem. And then we messed up. We forgot to mark the inside of the grid, and then it took us a while to figure out how to mark the inside of the grid. And then we finally did mark the inside of the grid, and then yeah. So it was just a little slow. Uh, I'll post the relevant part in Larry's Discord, but otherwise this is not that interesting. It's just point compression. Trying to alt tab into the right window. Larry's Discord. Create a thread. Create thread 2025 solution. New thread. No. 2025 day 9 solutions. Uh, okay. I don't know. I don't know if there's much else to say. I'm really sorry that my bandwidth sucks and it doesn't do the thing right. I don't know. Oh, it seems to be going better now. Takes 2 clicks. Um, Jonathan Ho got it really fast. Also a little bummed I was too slow to do part one. How much faster do I need to be? I needed to be just a little bit faster. Anyway, I don't know if there was an easier way to fill in the grid. I guess it's easy enough to fill the outside of the grid. It took me a second to realize that's what I forgot, and then so I had to do the test case, and then I had to do and then I had to run the test case to figure out why I was wrong. Or I had to run the sample input to be able to figure out what I did wrong, and then once I ran the sample input, it took a while to figure out what was wrong, and then I had to write the code to flood fill the outside of the grid. I don't know. I guess all that adds up to 45 minutes. Excuse me. Or 40 minutes. Yeah. Yeah, lots of debugging. I feel like if I didn't have any debugging, it would have been maybe closer to 25 minutes. Still probably would not have been. Oh, it might have been fast enough to have gotten another medal. I don't know. It's okay. A little slow. In general, as the problems get harder, I tend to move up. That also, that tracks. Anyway. Okay. I will end stream and bolt the laundry and go to sleep.